spectroscopy, and that will be concerning absorption and emission of electrons and light, so how light is absorbed and how light is emitted. And so that's going to involve electrons. In our last lesson, we learned about the components of an atom. So you learned about an atom is comprised of a nucleus, which has a proton, has neutrons, and it also has electrons. So you don't need to have all that background, but that's where we're leaving off from that last lesson. So today I'm going to ask for us to write three facts down that we know about visible light. Take your time, take a moment, write 3 facts down. Okay, so who wants to tell me one of their facts? Caleb.
Light travels faster than sound.
Does anyone want to shout another one out?
What you did, which is that's the color.
Very nice. Jamie, do you have anything?
I know that it travels fast.
Okay,
So,
I'll keep Caleb's up there if that's okay. Brad?
It's caused by electricity.
When you say it's caused by electricity, what do you mean?
Like, electricity makes there be light, like these lights.
Okay, so they power lights.
Sure.
Okay. Power energy.
isn't white when like all colors are being reflected?
Yeah,
And
white
black
light is
when
comprised
everything's
of.
being absorbed.
Correct. Yeah.
Refracted through a prism.
I'm sorry, what did you say?
Can be reflected.
Yes. And what is refract? What do you see when you put light towards a prism? What comes out? Correct. Okay, what do you have anything? Oh, okay. Yeah. Do you guys have anything different you would like to add?
I had that visible light was different from infrared and ultraviolet light, saying what it's not.
You are good. Do you know what makes them different? No, okay. Just curious, just curious. Anything else?
It's right.
Oh, neat, okay.
The wavelengths make them different.
Oh, more correct me. All right, so all of these are true. We're gonna explore what Professor, what's your last name?
Neely.
Professor Neely had put up. Visible light is different from ultraviolet and infrared light. Nate says that it's different because of their wavelengths. So we're gonna look at the spectrum. So let's start with radio waves. Now, if you look at the base down here, the wavelength, it's pretty long. These peaks don't happen relatively next to each other. There's a lot of space in between them. So if we go to microwave, we see that the peaks get closer and closer together, that our wavelength gets shorter. So if we go to infrared light, what do you think is going to happen? Or what do you see happening with the wavelength? Well, I'm sorry,
Greater frequency.
it is a greater frequency, and what's going on with the wavelength? They got shortened. So if we have a short wavelength and a higher frequency, relationship do we have between wavelength and frequency? One's increasing while one's decreasing. Correct. So they're inversely proportional to each other. So what we're doing is we're getting a greater energy with a higher frequency and a lower wave, or a shorter wavelength. So now we're going to go to visible light. In visible light, you can see up here they produce Roy G. Biv. So you can see red is at 700 nanometers, and it goes all the way to violet, which is 400 nanometers. If we go to UV, what do we predict is going to happen to our wavelength and frequency? Raise your hand. Nate?
We're gonna have a high frequency and short wavelengths.
Let's see if he's right. Correct. So, does everyone see how our wavelength got so much shorter and we got a higher frequency with that? Okay. Now we're going to do an activity. I need to know if anyone is allergic to winter green mints. Has anyone experienced allergy problems with winter green mints? Okay. All right. So I'm going to pass these out. Please, if you want one, you can have one. If you want two, you can have two. But I need all the lights to be off. So once I hand it to you, if we could all come up, if we could all just make 2 rows. I need you to have a partner that you can face because you need to see their mouth when they're crunching the mint. So if you guys could come up and make 2 lines and just see, like, have a partner across from you, that'd be great. Oh, I was gonna have you guys stand up. You can sit together if you want, that's fine. Yeah, so you guys just wanna have 5 people go down here, 5 people go down that row. You guys can just look at each other across the table. You guys want to?
Sure.
Professors, you can come up, you can do this too. So we have 1, 2, 3. I need 1 over here, and then if you 2 wanna try, you can.
I gotta record, sorry.
I'll be your partner. Okay. All right, so I have, you wanna take one, pass one down? You don't do 4. Sorry. There you go.
Get the lights.
Okay, you can put them in your mouth, but do not crunch them. Hi, sorry. Okay, on the count of 3, you are allowed to bite down. Please stare at your partner's mouth. You have,
Yes, you have to see inside of it.
okay, ready? 1, 2, 3.
Oh, wow.
Okay, did everyone see a glow or a spark? I did. I saw only 2 people saw it?
I saw one.
Okay. Do you guys want to try it again? You should see a spark. You guys want to try it again? Okay, let's try it again. If you, how about we have 2 people go behind this screen? You might see it better, but because there's not a lot of light. There's a lot of light coming in from that window. I'll put the lights back on real quick. Okay. So would you guys be okay with trying it back here for more time? Who else wants to try it? Okay. There you go. There you go. I'll turn the lights off. So we'll just have these two try it for the sake of time. Thanks for me. Thank you. One, 2, 3. Yeah. Okay, you can turn the lights on. Thank you very much. Okay. Sorry, I should not let a boy and a girl behind my That was very wrong. Okay. While we're discussing everything, I brought nail polish. If you want, you can. We're going to do an experiment with it in the class. So if you want, you can just pick one nail and paint it. Okay, what did you guys see? What happened? For everyone who did see something, what did you see?
Which, like, below where the can is,
Okay, so was it, what color was it?
almost a light
It was
blue.
blue. When did you see it? Was there a specific time that you saw it? Was it
Like the first, like, crunch.
the first crunch? Okay. Do you know, what do you know why that would happen, or what do you think caused that spark to happen on that first crunch? Any ideas? Okay, so let's think about it this way. When we put anything like this is composed of sugar, there's a lot of chemicals in it. We put it in our mouth and we break it down, all those molecules are being released inside our mouths. And what do we have in the air? Does anyone remember the 4 or 5 major elements that are in the air? Yeah? Say it louder.
Oxygen.
Oxygen, good, be confident, that's good. So we have oxygen, we breathe this out, we have carbon dioxide, good. There's also hydrogen, there's also nitrogen. So especially the nitrogen, when these molecules break down and they interact with the nitrogen molecules, they're having collisions occur. And those collisions cause electrons to get very excited. So when we have electrons go into an excited state, this is our ground state, and we have energy levels. And energy increases as we go up. So if we have an electron, jumps up to here, this is our excited state. This electron is absorbing light at this moment. So with gravity, anything that goes up has to come down. So this electron went up, what's it gonna do?
Come back down.
Come down. So it's gonna come to the ground state. It just absorbed light going up. What's it gonna do going down? Any ideas? Nate?
It's gonna give off light.
Correct. It is going to emit light. So that's what's happening. That's what just happened in your mouth that you saw. You saw electrons getting excited, absorbing light, and then dropping back down, emitting light. So when we have ultraviolet light, so anyone who painted their nails, I'm going to add this ultraviolet light, which has a, does ultraviolet have a higher, like a shorter wavelength, or a longer wavelength than visible light? Who remembers? Shorter. So it has more energy because it would have a greater frequency. So if I apply it to her nail, it's going to make her nail get excited. The electrons in the nail polish are going to get excited, and they're going to change colors because they're going to emit that glow. So I think it was plum, so it's a little purple. Okay, and I have beads that you can hand out, and you can play with the torch tube if you like, and you can see it happen. Pass it around. I also have cards. So these cards, they have a shield. So when you go out and you go to the sun, because that is an ultraviolet source, you will see the shield will change colors, and there's medium, low, moderate, high, and critical. So the sun giving you that ultraviolet, those waves that are penetrating you, that's why you get sunburn. So many of you have experienced that, I'm sure. So you can take one, you can take a bead, or you can play with the torch, just pass it down, experience that.
And there's your time.
Okay, sorry. It's better when I have a whole lesson, so that was going to adapt to. Sorry you didn't get to